Does that not give you guys a sheet? Oh, I'll get it to you. Three. So if I had to give you like, and you guys, it's not like you open up a book, they say, well, this is level 1, this is level 2, this is level 3. Lucas, did you get a sheet? So it's just Izzy and Nathan. Yeah, so it's not like you open up a book and you see like level 1, 2, 3, 4, 5. I'm just saying that there's a lot of like level 5 integration techniques, and they're all very difficult. If you know how to do this, you're in pretty good shape moving forward. But there's some really, really difficult integration techniques that you can learn down the road. And we'll investigate some of them. Let's try this. What would you choose you to be in this situation? Well, that's a very good choice, and you are correct. What's DU? Why is that problematic? Very good. Andrew? Say that one more time. Shh. I'm trying to hear Andrew, guys. I don't know. I'd have to work that out and see where we get. This is what you can do. No. You can't make 3 separate integrals. You can do this. This is what you want to do. Watch. Have I done anything crazy there? No. All I did is rewrite it as x squared times x. Now, do you see where this x fits in? Do we have to worry about the constant of 2? No, we can just divide the 2 off. We know that we get 1/2 du is equal to x dx. That's no problem. And we see the x dx. The problem is we have an x squared up there, right? And instead of having an x squared, what variable do we need? We need a u variable. You see? I took u equals x squared plus 2, and I rewrote it to be x squared equals u minus 2. So look at the substitution I have now. See this x squared? What I could do is I could put in u minus 2 for x squared. This x dx I replace with 1/2 du. What goes in for u squared plus 2? Or x squared plus 2? I put u in right there. So I have all my substitution things taken care of. So I have my integral, and we'll just write each part out. We'll start with the x squared. What do I put in instead of x squared? U minus 2. We'll put the 1/2 in there. Instead of the x and the dx, what do I put in? 1/2 du, so I'll put a half out front. I'll put the du on the end. And instead of an x squared plus 2 to the 5th, what do I put in there? U to the 5th. half times u to the 7th over 7 minus u to the 6 over 3 plus some constant. Whoa, hold on. Now we got to distribute the 1/2, and then we'll plug in the u part. And u was what? X squared plus 2? So we've got x squared plus 2 to the 7th over 14 minus x squared plus 2 to the 6th over 6 plus some constant. That's the answer. So we had to make an extra substitution there that we weren't maybe necessarily anticipating. But look at your final result. How would you have come up with that? I mean, you guys have done substitution now, and when you've done that substitution, you've said to yourself, well, I could see how when you take the derivative of that, you get the integral, you know. Well, look at this. Could you anticipate this from this beginning part? It's pretty difficult. You know, aside from multiplying this all out, you know, foiling it 5 times and then distributing x to the 3rd, you know, we were able to do this pretty quickly. Question. As calculus 2 moves forward, we learn that any function, whether it be sine of x or natural log of x, can all be written as a polynomial. And if you have a polynomial, you can take an antiderivative. So the TI-92s, which are a $200 calculator, can find antiderivatives. Your calculators cannot do this. They are not nearly as intelligent. So, but we are, so we can do it. Let's try the next one. All right, number 2. What do we choose u to be? X to the 3rd minus 4. Shh. What is du? Do you see a problem? Yes. So let's remedy that problem. First, I'm going to rewrite the integral above as 4 times the integral of x to the 3rd times x squared times x to the 3rd minus 4 to the 3rd dx. And this will be 1/3 du is equal to x squared dx. So what did you say, Devin? What do you want to do? Good. Devin and Tyler see that I rewrite x to the 3rd to be u plus 4. That way I have a substitution that works. Multiply my one thing by 4. Okay, so now you want to go to substituting everything. And that's the right move. So let's do that. Question. So that you can see that for this x to the 3rd, I plug in u plus 4, and this x squared comes from this x squared dx. Good. 4 over 3. Shh, boys. 4/3 times the integral of, no, not x to the 3rd, but u plus 4 times u to the 3rd du. Good. X to the third minus 4 is u, and that's the third power. Very good. You got it. So we should... Hold on, Tyler. I distribute. I get 4/3 times the integral of u to the fourth plus 4u to the third du. No, we haven't, and this is a mistake that people make a lot, and that just shows when you're starting to get a little overwhelmed. Remember, we still haven't taken an antiderivative, have we? In order to take an antiderivative, that's when you get rid of the integral and the du. So we haven't done that yet. So in order to get rid of this, you got to take an antiderivative. What's the antiderivative of u to the fourth? U to the fifth over 5. Very good. Plus u to the fourth plus c. Now I can distribute and make my final substitution. Isn't that cool? Question, Tyler. Oh, okay, so you see how you have x to the third minus 4 to the third? U is x to the third minus 4, and so I got to plug in u, and that's the third power. Now, you guys, something that's going through your head, though, well, maybe, is does this work for every type of situation? Don't. Very good, Mr. Hansen. If you were to see a problem like this, say x squared times 3x squared minus 5x plus 1 to the 15th power dx, you can't simply make that nice substitution and solve for it. So the technique that we're using doesn't necessarily work out in this situation. So, no. So, let's go back to other types of problems that will work out in our favor. And let's try a trig problem. Yeah, I can't hear any of you guys. You can only hear me. Yeah. So I like talking to myself. No, I like talking to you, Marlene. All right. Okay. What do you want you to be? Okay. No. Not u as an x. We want you to be cosecant of x. Very good. Now, you guys, trust me, you don't, well, 90% of you don't see it all yet, okay? There's a trick here. No, that has nothing to do with trigonometry. What's the derivative of cosecant? Negative cosecant of x, cotangent of x. Now, when you look up at the problem, do you see, you see a cotangent, right? But you don't see an extra cosecant, do you? So here's a trick. I'm going to rewrite this to help me see this piece right here. Watch what happens. I have the integral. And instead of cosecant of x to the fourth, I'm going to rewrite it as cosecant to the third times a cosecant of x times a cotangent of x dx. No. Yeah, all I did is just pull out a cosecant. Some may say. Do you see why I did that? Now I have negative du is equal to cosecant of x, cotangent of x, dx, which is my substitution right there. And this u equals cosecant of x can be plugged in right there. Yep, I'll put the negative out front. So I now have an integral that's negative. So instead of a cosecant to the third, I have u to the third. And instead of a cosecant of x, cotangent of x dx, what do I have? Negative du. I've got the negative out front. Now I just have a du. What's the antiderivative of u to the third? Negative u to the fourth over 4 plus c. Beautiful. Good question, Ina. That is cosecant to the fourth. Cosecant to the third times cosecant is cosecant to the fourth. You're overthinking it. Oh, my Lanta. There you go. You got it? Okay. All right. The last one is pretty involved. Oh yeah. All right. Are you ready? Okay. Here we go. Trust me, you guys. You'll have to really exude your patience here. This will be difficult. Yes. U equals 3 minus x. We're off to a good start. What do we have up there that we need to account for? A 3x squared. You can get rid of the, you can move the 3 out front, right? So I'm going to rewrite this to just be, 3 times the integral. And you don't have to rewrite it like this. I'm just going to do this to try to help you. X times x over the fourth root of 3 minus x dx. So, can I solve for x here? Yeah. So we have negative du is dx. So we have that substitution we can make. And as Chrissy said here, you end up with x equals 3 minus u. Very good. So instead of x equals that, we have x squared is equal to 9 minus 6u plus u squared. Right? So I'm pretty close to now making my substitution. Let's do this. We've got a negative 3 out front. We've got the integral. On top, instead of x squared, I can write u squared minus 6u plus 9. I'll write it like that. Over u to the 1/4 du. So if we have a u to the 1/4 on the bottom, what should we do? Divide everything by u to the 1/4. Sure. You know, if you have like 4 plus 2 divided by 2, you can't cross off the 2's, but you can divide the 4 by 2 to get 2, and the 2 divided by 2 to get 1. So you can do that. No. No, no. All right, so we've got u squared divided by u to the 4th. So we subtract those exponents, right? Instead of a squared, that would be 8 over 4. So what is 8? U to the 8 over 4 divided by u to the 1/4. U to the, good, u to the 7 over 4. Minus, so this is 6u to the 4/4 would be 6u to the 3/4 plus 9u to the negative 1/4 du. Everybody got that? Good. Now we get to take the antiderivative. What is the antiderivative of u to the 7/4? It's negative. It was u to the, it's 9u to the negative 1/4. So when we add 4/4, we get 3/4, not 5/4. So now we need to, instead of divide by 11/4, we multiply by the reciprocal. And remember, you got to distribute the negative 3 through. So you'll have a 4 on top, right? So it'll be negative 12 u to the 11/4 over 11 plus, let's see, 4 on top, so it'll be 24 times 3, 72 u to the 7/4 over 7 minus 4 times 9 is 36, and 36 times 3 is 108 over 3 plus c. And now we should make our substitution, which is 3 minus x. And then we're done. Jacob's so moody, isn't he? He's a moody kid. And that's it. Now, again, but I can see it on Kelly's face. She really finds it impressive. I know that for sure. But when you look at it right here, again, as you see this, could you have anticipated that that would be the antiderivative when you look at the initial type of problem? Oh, Katie Williamson sees an issue. Good job, Katie. What's 108 divided by 3? 36. So I'll just write it one more time. You guys don't have to. I would dock you points on the test, rightfully so. And you should be able to do a problem like that for the test. And you will be able to. They did last year. It should look worse than what you started with. You're taking an antiderivative. We're not trying to write this in a nicer way. We're trying to take this and find an antiderivative. But we did it. We'll see. We won't be ready to test on Friday, but there's just so all we have left is just one small section. So what I'd like you to do is raise your hand if you are completely done with 1 through 22. Okay, so a couple of you guys. So you had 1 through 38, then you had 1 through 22. Now, I said that 1 through 38, I need that tomorrow when you leave class. That was what I told you before break. So now 1 through 22. So 1 through 38. 1 through 22 I'll collect by the end of the week. Now, I will give you guys some time to work tomorrow, but let me give you some problems like this that you could start on in your book.